send it over to Vinay. Any particular question that you have, but we have to go to our next speaker. And our next topic for today is overview of artificial intelligence and machine learning. Learn the basics behind artificial intelligence, machine learning, deep learning, and neural network. And to talk on this, we have a very young speaker who is the lead engineer at Penny and founder of Tribotics. He also has been a Google I/O speaker, Google crowdsource speaker, in 2019, all of this, Global Azure Bootcamp speaker, a judge, mentor, and speaker at Utkal Hacks first ever hackathon at the Silver City of Orissa. So he has whatever he has the technical part of it. But one thing that I noticed after talking to him is he is super energetic and super excited always to learn new things. And for you, our next speaker, Karan Shaw. Karan, if you would
Yes.
video on.
Yeah, yeah, Julan, thanks for this warm welcome. Okay, so yeah, let's start with the thing. Let me share my screen. Yeah. Okay, so Julian has already given my introduction, but I'll give a small introduction about myself. I'm a lead engineer at Penny.co. It's a Dubai-based company, and apart from that, I've also worked with as a head of engineering in RefTap.ai. I was also the ex-CTO of Prographer, and I'm also the founder of Tribotics Innovations Private Limited. So from last 5 years, I have totally worked on AI ML products. These products were, some products was a fintech company, somewhere regtech company, somewhere edutech companies, so somewhere logistics related companies. So with these companies I've worked and I've explored that how they're integrating the AI and ML in order to solve the real world problems. So what I will do in this session, I'll give you the overview of AI and ML and deep neural networks, and how practically different companies are using on their products and how they are getting benefit about it. So let's start with this session. So these are my teams. These are the few events which I've done previously. I was also the speaker of Google I/O, Google Crowdsource. I'm also a public speaker. So I love to share my knowledge with young people and the people who are willing to learn new things. So yeah, so let's start. So so before starting, I would like to give you a small intro on basically on artificial intelligence and machine learning. So artificial intelligence is an area of computer science that emphasizes on intelligence machine and how they behave and react like human beings. So some people have misconception that what exactly the AI means. So AI is something you're making by utilizing computer science, you're making intelligent systems. So then what is machine learning? So machine learning is an application of AI that provide the program an ability to learn it by itself. Hello. Yeah. AI itself is a very big domain. It has many branches and sub branches of it. If you see here, so AI has branches like machine learning, expert system, speech recognition, vision recognition, planning, robotics. Lot many areas are there. Under machine learning, we can see deep learning, supervised learning, unsupervised learning. So if you see natural language processing, under language processing, we have text generation, question answering, and machine translation. Lot many things are there. Like we use a voice recognition system that also comes under natural language processing. We have expert system, we have robotics, we have computer visions. So lot many, these are the sub branches of artificial intelligence. Okay, so you can see that these are the few areas where we are using machine learning in order to solve the problems, like in a Google self-driving car. natural language processing has been used with the Google Voice. And when you're doing audio to when you're transcribing that audios, at that time we are using natural language processing. In robotics we are using reinforcement learning. So that's all about this. So so if you see here, so artificial intelligence is have many subsets. So you can see the machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. So this is the more deeper classification of deep learning. Is you can see here. So let's understand how this technological evolutions happened. So if you see, when we were standing in 1915, at that time the term AI ML, this artificial AI has been term, and at that time we learned how to program, how we can make a auto playing chess game, and how we made how the bot can play a chess game. And later on we entered in 1980s, we entered the era of machine learning, where we learned how we can do spam filtering, where we learned how we can do basic classifications, we learned how we can do fraud detections. Those kinds of things we learned when we entered in 2010. We entered in an era of deep learning. We started using deep neural network, and after that it made us very easy to classify any image. We started exploring more on computer vision. We learned how we can classify the image, how we can stitch the image, a lot many things. In the further slide I will show you that how deep learnings is solving very critical problems in regtech, biotech, or fintech companies. Okay. So yeah, so the applications of machine learning, I think you already knows that virtual personal assistant, that is Google Assistant, Alexa. If you see social media services like face detection in social, if you upload any photo in Facebook, you can see that photos got auto tag. It tags your friends by default. So that is the feature of face detection, friend suggestion, news feeds, advertisement. And in the email you can see in your Gmail, you can see that there is a spam filtering does. So all your promotional mails goes to your promotional section. All your spam mails goes to your spam sections. So there also we are using machine learning. So even online customer supports after this COVID, I've many companies for their customer support, they are using chatbots or humanoid related chatbots who can talk like humans. And even search engine optimize search engine results also, they are also very good. They are using machine learning in order to give the better search results, and a lot many things. Okay, so if we go deep inside machine learning, we have three main different kinds of categories. One is supervised learning, one is unsupervised learning, and one is reinforcement learning. So by the image, you can understand that supervised learning is where you have a data, and where your algorithms, in order to feed data to your algorithms, you have to classify it, or where you have to teach your algorithm that okay, this is the X data, and putting this the X data, you will get this Y data, like that. And from that X and Y data, the system tries to learn and try to build the model. But in unsupervised learning, by the word itself suggests that it's unsupervised. You just put your data and your system will classify by itself. It will group it by itself. It will try to find the hidden pattern inside it, that we are doing inside a new deep neural network. And reinforcement learning is something where it's not it's taking the advantage of supervised unsupervised learning techniques, and also it's taking a live feedback from the environment, and on the basis of that it takes decision. Mainly it is used in self-driving car, in robotics, because the training which you have provided, that taking the advantage from that. But even the images which the car is capturing, and even the sensors data, on the basis of that the car is taking decision whether I have to move forward or I have to stop, and how much speed I have to how much I have to do the speed up I have to speed up the car. So those all these decisions is taken on the basis of their live feedback, what it gets from the environment. So that comes under reinforcement learning techniques. So yeah, so if you see here, so under supervised learning techniques, we have two classifications like classification techniques and regression techniques. Under regression, we have simple regression, multiple regression, linear and non-linear regressions. And under supervised learning, we have clustering techniques and association techniques. And under semi-supervised learning, let me talk about the semi-supervised learning. Semi-supervised learning is a learning. It's a combination of supervised and unsupervised learning techniques, where your some of the data are classified and they have proper labeled, and some data are not having proper labeled data. So in that kind of situation, you're going to use unsupervised learning, semi-supervised learning techniques. And reinforcement learning, I've already told about that. It takes the feedbacks from the live environment also. So the feedback can be negative feedback and positive feedback also. Okay, so if you see this tree, so you can understand here under supervised learning techniques, there are many different algorithms to solve particular problem. If you see, if you're having something, if you have a data where the data which are, if you're having some data which are already labeled, so you can go with supervised learning techniques, because you have your data are supervised, your data are labeled, it already knows the answers. So in that situation, we'll go with supervised learning techniques. Under supervised learning techniques, we have many different algorithms like regression, decision tree, random forest, classifications. Under classification technique, we have different algorithms like k nearest neighbor, logistic regression, Navi's bias, support vector machine. Under supervised learning techniques, as I told, under unsupervised learning techniques is where you have only the data, you don't have the label, and you want your system to detect the label by itself, or you want the system to group it by itself. So under that thing, we go with unsupervised learning techniques. So unsupervised learning techniques, under unsupervised learning techniques, there is clustering, there is association, and if we go with the reinforcement learning, so if you see this, they are supervised and unsupervised. They are further classified like continuous problem or categorical problems. So categorical problem where you can categorize it, okay, and continuous problem where you can't categorize it. So let me go further and give you some more deep examples. So yeah, so you can see here, so under supervised learning, we have classification and regression. So what areas we are solving? Using classification, you can solve fraud detection, you can do image classification, you can do email customer retention, you can do diagnosis. So under regression, you can do prediction, new insights. Under reinforcement learning, you can do robotic navigation, skill acquisitions, learning tasks, AI games. They all come under reinforcement learning techniques. And if you see the unsupervised learning, so under that we have, as I told, the clustering and association. So using clustering, we can do customer segmentation, target marketing, recommended system. And under reduction, you can do structuring, structured discovery, feature detections, meaningful compression, big data visualizations. So these are the few things. By seeing this picture, you can understand that which areas and which domains the AI and MLs are solving. Okay, so let's understand more properly that what is supervised and unsupervised. Maybe in the further previously you didn't get more better and understanding. By seeing this image, you can understand that. Uh, you can understand here that suppose I have labeled data, which I told in supervised learning, we have labeled data. So like we have the images of the birds, and we have already labeled it like duck, non-duck. So when you train your model and you give a new bird image, so it can predict whether it is duck or non-duck. This kind of algorithms we call this kind of techniques we call supervised learning techniques, because here you have a labeled data. But what if you don't have a label data? So if you don't have a label data, then we go with unsupervised learning techniques. So here you don't need any supervision. Your algorithms by itself, it will create some pattern on the basis of structure, colors, and lot many other things, and it will try to group it. It will try to using clustering technique, it will try to group it on the basis of the various features. So here the system by itself take decisions. And reinforcement learning, I have already given you the example. Suppose if you take a robot and you want to solve this problem. So but when you're so the robots, what it does, it takes a live feedback from the environment, and by the basis of that, it takes decision. So, let's go more deep inside machine learning. As I told, it's the deep learning is a subset of machine learning. So, what improvement we got after 2010? What improvement we got in deep learning? So, you can see here that in machine learning, there were four steps involved, like input, then you have feature extraction, then classification, then you get the output. But in deep learning, what problem we solve using deep neural network, the feature extraction and classification happen inside one method, inside a one step. So this was one greatest achievement, because we did not need to always put some we in this, actually the deep learning, if you have a huge amount of data, so this neural network performs very good. So in the further slides, I'll show you that how it does. So this is the few practical examples. Suppose you have labeled your image that where is chair and where is furnitures, where are swimming pools. So after training on the neural network, you'll get a classified data, like by classifying that okay, in this image we have swimming pool, in this image we have chairs, furnitures, like that. So yeah, so let's understand what is deep learning. So but deep learning is I have given a very simple example here. So we have an input, we have two hidden layers, and we have an output. So in the magics actually the magics actually happens inside your hidden layer. So if you see more properly, you can see here. So we have an input layer, and then we have two hidden layers. So then in the hidden layer, you can see in each layers, the deep neural networks performs the feature extraction. You can see in the one layer, it is extracting all the eyes, nose, and all the different features. And then it does the face extraction, and then it predicts the output. So what we do when you upload your photos, so your Facebook by default it tags your friends. So this is what the Facebook does internally. It takes the photos, it extracts the features, and by extracting the features, it tries to understand that with which image it is matching, with which of your friends in your friend list it is matching, and by that it tags the friends by default. So I don't want to go inside more deep inside this, because we have a very less time. So this one more thing I will talk about this. There is forward propagation and backward propagation in deep neural network. So if something, if the machine is, when we are training in the deep neural network, if the desired result doesn't come, then it goes for backward propagation. It corrects the weightage, and again it does the same thing. Okay, so yeah, so this is one image. By seeing this GIF image, you can understand how the whole things happens. So you have a training data, then you decide your ML algorithms on the basis of what kind of data you're having. Do you want to do supervised learning or unsupervised learning, or do you want to perform and what kind of algorithms you're going to use? You're going to use KNN networks, or you're going to use support vector machine on the basis of your data. So you're going to produce your models, and then you have a new data, then you feed your new data into your ML algorithms, and then it's going to predict some output. And if you're not getting desired output, you can use reinforcement learning in order to retrain your models. Okay, so now the application. So some of the practical examples I'm going to give you in this. So in ProGrapher, when I was working with ProGraphers, so there I worked with how we can increase the image quality, how we can increase the, if suppose you're having a low resolution image, how we can increase the image quality. You can see here the frog image that is little bit blur when you zoom it. Then after using a deep neural network, we are able to produce this fine output. So one more practical example I'm going to give you here. So you can see before and after, you can see here. So after doing a 4x zoom, so the image got blurred. So when we pass this image with when we train our AI and ML algorithms by using deep neural network and TensorFlow, we are able to produce this kind of output. You can see that the image is so clear here. One more example, I will give you this example. So you can see the before image. So, and after image, in the after image, you can see the sky is little, it's more bluer. You can see the swimming pool is more bluer. So what it does, as I told, we train our deep neural network that if you find any skies, then you make it little bit bluer. If you find any trees or something like that, so you make it more greener. If you find swimming pool, you make it more bluer. So like that, you can see that by using AI and ML, we have produced a tremendous output here. With the food also, we previously we were also working with Swiggy for food photography. So this is what we when we get the photos from our photographers, so before the image and after we pass it this image to our AI and ML algorithms, we get this kind of output. You can see the colors, and all the colors are coming so clear. They are so prominent, looking so prominent and tempting. Okay, so this is also one example I can show you here. So you can see before we have two image and we wanted to stitch it together. So when we were using we were using simple machine learning algorithms, you can see the image has been stitched, but it has not blended properly. But by using deep neural network, you can see the third example. You can see how well the image has blended. So this is the main advantage of deep learning, where you get more prominent outputs. Okay, so yeah, so that's all. These are few references I think you can take. uh, Let me know if you have any questions. Yeah, thank you.
Yeah, thank you so much, Karan. And yeah, but now next time, the only problem with this super innovative and AI and MI and everything that you actually forget how things look in its original form. So that's the only issue here. So better, yeah. But it was a terrific presentation. Thank you so much. Thank you for keeping
Thank
it. Best the time that was given to you. And yes, anyone, if you have any questions, please put it in the chat. We'll try to take it. If we can, if we have some time, or we'll definitely, as I said for Vinay as well, that we'll have him, as the feedback we get, we'll have him definitely for an 1 hour session as well.